Okay, welcome along to homework hashtag number 4. I'm just going to double check that I'm recording. Yes, I am. Fantastic. Apologies, this is a little bit later than usual coming out. It's been a really busy week marking the papers and everything, but hopefully we can get back on track. So we're looking at homework hashtag 4, which is looking at cumulative frequency and standard form. So the cumulative frequency section is the content we've covered in class this week, and standard form is the topic from last year. Okay, so let's read up the title. It says this homework comprises of 2 sections. Section A is cumulative frequency, which would just be this video, kind of like so part A, which is work you've been through this week with me in class. And section B is standard form, which is a topic you've done last year. So it's revision to make sure you are fresh and up to date with the topic. Okay, so a bit below, remember to use the video solutions is what you're on right now. So hopefully these are going to be useful and you can self-mark your work and you can come to me if you need any more help. But without further ado, let's begin with section A on this first question. So question number 1, which says the following. So here is a list of 11 whole numbers, as you can see here, in numerical order, so from smallest to biggest. The lower quartile, the median, and the upper quartile and the highest value are missing. So this is the lower quartile, okay, the 25th percent value. This is the median, the 50th percent value. That's the upper quartile, 75th percent value, and that's the highest value. And you've got some information here. The median is 2 times the lower quartile. So this middle number is double the lower quartile. Let's just begin by looking at that first line. Now, I'm just going to be using trial and error here by looking at the question. Again, I'm doing this off the cusp, okay? So kind of like how you guys can approach it in the exam. Now, let's just pick a value here. For example, 9. Now, 9 would not work because if it was 9, okay, the median would be twice this lower quartile, and double 9 would give you 18. Well, clearly that can't work because this is now not in numerical order because 18 is smaller than 19. So 9 doesn't work. We could try 10. Okay, 10 would work. If you double 10, you get 20. Okay, so far that is being satisfied. That's good. It then says the upper quartile is 2.5 times the lower quartile, or 2.5 times by 10 is 25. Okay, and that does not work anymore because, again, this is now no longer in numerical order. So that doesn't work. It's no good. Now, 11 also wouldn't work. We could just try 12. Okay, so 12 here should work. That's my lower quartile. The median is double this value. Double 12 gives you 24. Okay, and this makes sense because, well, it doesn't make sense, but it's allowed because it's still in numerical order. And what is 2.5 times of 12? Well, 2.5 times 12. Okay, well, 2 times 12 gives you 24. Half of 12 is 6, gives you 30. And this does work nicely because 30 is in between 28 and 34. Good. So I've done the first condition and the second condition is satisfied. It then says the range is twice the interquartile range. And remember, the interquartile range is the upper quartile. Take away the lower quartile, where this is my upper quartile. This is my lower quartile. So it's going to be equal to 30, take away 12, which gives me 18. Okay, so this is the interquartile range, 18, but the range is double this value, so it's going to be 18 multiplied by 2, which is 36. Now, that's not the answer for up here. The range is 36, okay, which means from the smallest value to the biggest value, there's a difference of 36. So to get this value up here, I'm going to go and do 5, add 36, which gives me 41. Okay, so this final value should be 41. And let's check the mark scheme. So we've got 12, 24, 30, 41. Perfect. So quite a nice kind of problem-solving question to begin with. Okay, I know this kind of question can freak people out, but you've just got to break it down one thing at a time. Okay, and with practice, you can begin to really nail these questions. Okay. Question 2. Type A batteries and type B batteries were tested. The cumulative frequency diagram shows the information. The cumulative frequency diagram shows information about the battery of type A. I'm presuming that's going to be on the next slide. There we go. Good. So this is type A up here. Cumulative frequency and battery life. estimate the interquartile range. Okay, and remember, the interquartile range is the upper quartile. Okay, in other words, the 75th percent value, take away the lower quartile, which is the 25th percent value. So if we look at our data, there's 80 batteries in total. That is your total. So you want to find 75% of 80, okay, which is 60. Okay, 3/4 or 75% of 80 is 60. So I can go and draw a line at 60 going across and then going down. Okay, so this is going to be my upper quartile, which you can clearly see, right, at 60, that gives me a battery life of 1,400. Perfect. So 1,400. I can take away my lower quartile, okay, which is the 25th percent value of 80, or a quarter of 80, nice and easy as 20. So 20 is going to be down here, across and then down. Okay, so my lower quartile is equal to 1,100. Okay, so 1,100. That's my interquartile range. If I take those away, I get 300. So that is my answer. Okay, 300 for the first part. There we go. Just double check the mark scheme. Good. That is looking correct. Perfect. So these are the kind of things, guys, right? If you're not practicing exam questions, this is really easy marks, isn't it? It's just basically reading a graph. And then, you know, and if you do this for every topic or all the homework I give you guys, you're going to see so quickly that actually there's loads of accessible marks it. But if you've never practiced the questions, then you're going to be stuffed because you won't recognize what to do. But it's the same kind of questions over and over again. For example, part B now says, estimate the number of type A batteries that have a battery life of more than 1,600 hours. So the thing to go and do here, guys, is to go and find, well, where is 1,600 hours on our diagram? And let's go and do that. Well, that's going to be going up here. Okay, so we can go up and then we can go across over here. Now, if the battery life is more than 1,600, you're looking at everything to the right of this number. So everything to the right of the number, everything over here. Okay, so for example, you would want this value, which would give you this number. You would want maybe this number, which would give you something up here. So everything to the right of this means everything above this here. Okay, so you want everything above this here. Now, at 1,600, this reading across gives us a value. These squares are going up in twos, aren't they? So 72, 74, that's going to be 76. So this point here gives you 76. Well, everything above 76 to 80 is 4. So this difference here from 76 to 80, you can show the working, which is just 80, take away 76, gives us 4. Okay, that is your answer. Again, really quite easy marks there, and it's just recognizing and practicing this kind of question. Okay. Part C says the box plot shows information about the battery life of type B. So hopefully on the next slide, there we go. Okay, on average, which type had the greater battery life? Give a reason. Sorry, using data from both diagrams states how you choose your answer. Average, right? We've been talking about this loads in class. Okay, averages is either the mean, the median, or the mode. Now, from a cumulative frequency graph, which is this thing over here, and from a box plot, which is this thing over here, you can get the median. So the average we're looking at this case, in this case, is the median. So let's go and get the median for type A batteries using the cumulative frequency graph on the previous slide. So let's go and do this in a different color. The median is the 50th percent value. It's the halfway mark. Half of 80 gives you 40. So go across and then go down. This one's not quite as easy to read off. I'm going to zoom in. Oh, I've gone the complete wrong way there. I'm going to zoom in so I can see what's going on here. That looks fine. Keep going down. There we go. I'm going to say these are going up in 200s, 4, 6, 8, 200s, 2, 4, 6. Yeah, that's going to be about 1,260. That median, I would say. So for type A, the median is 1,260. Okay. And then for type B, okay, the median is on the box plot. Remember, the middle line is the median, which is easy to read on this one. It's just 1,300. So 1,300. So now that's going to be 1 mark straight away. I've got out the values. So on average, which has got the greater battery life? Well, it's got to be type B, because the median is bigger. So on average, okay, type B has a greater battery life. So we're going to go and tick B, and we're going to go and type in our answer and state it really, really clearly. So we can go and say type B, because the median 1,300 is greater than 1,260, and that's going to get you the marks. It's that simple. You don't need to go and write a big, massive essay. What the mark scheme is looking for is giving a correct conclusion. So giving out the numbers, right? These are your numbers for the median, and just saying type B, okay? And that's it. That's going to give you the 2 marks. Now, again, if you don't practice this kind of question, you're going to just be getting it wrong, and it's going to seem really alien in the exam. Once you do a few of these, it's the same thing over and over again. You're going to be given loads of questions that look like this. You had one in the mocks that came up that people answered really poorly. It's not because you can't do it. It's because you're not exposed to the questions. Okay, so that is why we've got to be nailing these homeworks. Okay, sorry, I'm speaking like a madman at the moment, but it's so important that we're just doing these. Okay, right, sorry, question number 3. New question. Let's have a look. 100 men and 100 women took a test. Okay, nice. Men, women, you got the median, the interquartile range, and the range. Remember the median. I'm not even reading the question, but I'm just thinking, right, the median is a measure of average. And then these two here, the interquartile range and the range, are measures of spread. Okay, so how varied, so it measures spread, or how varied your data is. It says, using the data above, which statement must be true? Does it go on to the next page? Yes, it does. So which statement must be true? Men had a higher average score than women. Well, the median for men is lower, so that one's definitely not true. Okay, because remember, the median measures average, and the men's score is lower than women, so that one's definitely false. Let's go on to the next page. Men had more consistent scores than women. Now, consistency, okay, means spread. They mean the same thing, so consistency, okay? Now, if you're more consistent, your interquartile range and your range should be smaller. Now, for the men, the interquartile range is smaller and the range is smaller, so this is true, okay? Because these values are smaller, there's less variability, which means less variability means more consistent. So that one should definitely be true. Okay, is that question number, what question is that? Good. Okay, so that's fine. That's the answer. Good. Question 4. We've got this table here, which again is... Oh, God, what's happened there? Question 4. I've just lost the question. Where's that gone? There it is. Question 4 is here. 24 students took a test. The table shows information about their marks. So between 20 and 40, you had 3 people. Between 40 and 60, you had 5 people, so on and so forth. Draw a cumulative frequency. Remember, cumulative frequency, guys, is your running total. So you're going to have to go and kind of add up those frequencies row by row in a second. And they don't kind of complete the table for you. So over here, I'm going to extend that table, which is what you guys are going to have to do as well. I'm going to go and add in, because we're looking at cumulative frequency, a cumulative frequency section, which again is the running total. So in the first row, you've just got 3 people. So you just go and put 3 in that section over there. That's to make it look a little bit neat. Okay, well, let's always make things look nice and neat. There we go. There we go. And there we go. Now, in the second row between 40 and 60, you've got these 5 people and the previous 3 people. You add them, you've got a total of 8. So cumulative frequency is saying less than 60, which is everything below 60. So this and this, there's 8 people. The next row, everything below 80, okay, it's going to be 12, add 5, add 8. Okay, so basically just 12 and 8 will give you 20. You just add together the frequencies. So the last one, you do 4, add 20, which gives you 24. Okay, now hopefully I can find a way of actually cropping this here so I can get it onto my next slide. That'd be really useful. If I can add to library. Okay, so I'm just trying to work out a way that I can get this onto the next page. Let's see if I can insert this. I'm not quite sure. Maybe over here. Sorry guys, if I can't do this, it's fine. No. 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 Is that it? Aha! Is that it? Oh, there we go. Amazing. Yeah, that's so really useful to know. Sorry guys, I'm just playing around with my technology. That's really useful. So now I've got it on the same page so you guys can see what's going on. Nice. So now I've got to go and draw the cumulative frequency diagram. So I've got cumulative frequency on the y-axis always, which is this part here, and I've got the mark over here. Now you always plot the end values with the cumulative frequency. So the end value with the cumulative frequency. Okay, and then that's going to be fine. And a cumulative frequency graph always begins at the point 0, 0. Okay, I should be really using a cross, okay? And it should hopefully be that kind of distinctive S shape. So the first point, 40 with 3. Okay, that's going to go 40 and then 3. If I'm a little bit out, it's hard to see on the screen, but that should be 40 with the point 3. That one's done. Good. I've then got 60 with 8. So 60, this is hurting my eyes a little bit, sorry guys. 60 with 8 should be there. If I'm a little bit out, guys, I'm really sorry, but I'm just trying to do this quite quickly for you. There we go. Of course, you guys make sure you do it really accurately and neatly. I've then got 80 with 20. Okay, 80 with 20 somewhere up here. 80 and 20 is up there. Good. Okay, and I've then got 100 with 24. 124 is up here. Again, I really hope that's matching up. 100 with 24. Probably go a little bit higher just to be careful there. Up there. Good. And then you've got to make sure you join the points with a distinctive smooth curve. And I'll do my best to do this for you guys. So there we go. Up there. Nice. And then up here. And up here. And we just finished up there. And you can see here you've got that beautiful cumulative frequency S-shaped curve there. Done. That's it. 3 marks in the bag. And again, if you don't practice this, you're losing out. And these are really easy marks. This maths, guys, is not difficult. You can do the maths. It's just practicing it in the questions. It then says, use the cumulative frequency diagram to estimate the interquartile range. We've now seen this before so many times, okay? But let's go and write it down again. The interquartile range is the upper quartile. Take away the lower quartile, well, that's your 75th percent value. Take away the 25th percent value. Now, 3/4 of the total, which is 24, well, what's 3/4 of 24? Let's write it over here. 3/4 of 24, okay, gives you 18, because 24 divided by 4 is 6, times it by 3 gives you 18. So the upper quartile is going to be the 18th value over here, and then down, okay, here. And that gives you a value of 78, hopefully. Okay, so upper quartile gives you 78, and we're taking away the lower quartile. So I'm just logging onto my mark scheme. There we go. The lower quartile is going to be the 25th percent value, or the 1/4th value of 24. So you now want to go and find 1/4 of 24. Okay, 24 divided by 4 gives you 6. So we're looking at the 6th value. We go across, and then we go down. And because, right, you've drawn on your curve here, your numbers may vary a little bit, okay? Because depending on how you draw your curve, this line may change a little bit. But for me, I'm getting 52 down here. So there's going to be a range of answers here. If we take those two values away, we get 26. So we get an answer of 26. Okay, but again, the mark scheme is going to give us a range of values, hopefully. Okay, let's have a look. So, yeah, there we go. That's fine. Again, depending on what you've, how your curve looks, you might have a value that's pretty close to this. Okay, so if you've got 25 or 27, as long as it's very, very close to that number, you're going to be good. Okay. Fantastic. Question 5. is the following. What percentage of a distribution is covered by the interquartile range? Well, we've just seen it up here, okay? The interquartile range is the 75th percent value, take away the 25th percent value, and 75 take away 25 is 50%. So that's simply the answer. An easy mark once you understand what the interquartile range is, okay? Question 6 is this. You've got a new cumulative frequency graph of 50 apples, as you can see up here, 50 apples. Use the graph to estimate the median mass of the apples. Okay, so the median, again, is the middle value. Well, what's half of 50? 25. So let's go and locate the 25th value, which is going to be up here. 25th value, we go across, we then go down, and that's going to be giving us a value of 106. Okay, so this number down here is 106. So the median mass of the apples, 106. Easy mark. Done. Estimate the proportion. So you want a fraction here. Proportion means fraction. Okay, so proportion, the keyword there, is asking for a fraction. So out of the total, okay, which is 50, of apples that have a mass greater than 115 grams. Again, let's locate that number, 115 grams. That's going to be mass is here, and 115 is up here. So we go up, and then we go across over here, and that number is going to be 42. Now, everything greater than 115 is everything to the right of 115, like 120. So this number, or for example 130, which would be somewhere up here. So everything bigger than 115 is going to mean everything to the right up here, which is going to be everything above this number. So you want everything above 42. So from 42 to 50, that's the difference of 8. So you've got 8 apples above 42. Okay, so you've got roughly 8 apples above 42. So the proportion here, okay, is going to be 8 over 50. Okay, and that's the answer. Okay, you could write it differently if you wanted to. So that's one way of writing the answer. 8 over 50. You could simplify it to 4 over 25, or even write it as a percentage. Double that to get it out of 100. Okay, which is going to give you 16 over 100 or 16%. So any of these here is what you want. Okay. Perfect. Question number 7 says this. The same students take 2 tests. The scores out of 50 are represented on the cumulative frequency graphs on the next page. So there you go. So you can see you've got test A and test B over here. How many students took each test? Well, that's going to be the number reading across, which is going to be 80. Okay, so that's going to give you 80. Good. This number, 80. Work out the median score for each test. Now, before I'm even going further here, I'm already anticipating the questions that is then going to go and say, compare the averages. Okay, I'm assuming, or compare the range or something. So the median, again, is the middle value of your total, 80. So you're looking here at the 40th person, so we can go across for both, and then we can go and go down, and then down over here. So the median for test A, this graph here, is going to give you 20, and the median for test B, which is this curve over here, is going to give you 35. There we go, 35. Done. Part C, the interquartile range for test B is 13. Work out the interquartile range for test A. So they've already worked out for us for a test B, which gives you 13. Okay, perfect. Do the same thing for test A. So remember the interquartile range, I'm going to write it out again, okay, because it's always a good thing to do. Interquartile range is the upper quartile. Take away the lower quartile, where the upper quartile is the 75th percent value. In other words, the 3/4 value. The lower quartile is the 1/4 value. Well, what's 3/4 of 80? 60, 20, 40, 60, 80. So 60 So we're going to go and read across the 60th value. I'm looking for test A, so down here. Okay, then down here. So this is the upper quartile, which gives you a value you can see of 25. So 25, take away the lower quartile, 1/4 of 80. 80 divided by 4 is 20. So we read across from 20 for test A, and then we go down, which gives you a value of 15. So the lower quartile is 15. 25 take away 15 gives us 10. Okay, so the interquartile range is going to give you an answer of 10. Now you can see here again, guys, if you practice this, right, it's the same thing over and over again. These are really easy marks. The only reason you're getting the stuff wrong in the mocks is because you're not used to seeing the questions yet. Once you know how to answer them, they're easy marks, and you can see, right, this is already 5 marks straight away. If you had never seen this before, you're going to get a 0. Okay, and that's obviously not good. And then we can go on to part D, and we can interpret it, right? Because which test is more difficult? Give one reason to support your answer. You could write different things here, but just choose something, right? So I'm going to be looking at the average, right? The average. It's either going to be the average, okay, or the spread, the variability, okay, the fluctuations. Now let's just pick the average. Okay, whenever you're comparing data, it's either the average, the mean, the median, the mode, or the spread, the range, or the interquartile range. Now, if we look at the average, okay, for test A, it was 20, and for test B, it was 35. So test B had a higher median, which means, well, if we look at test A, test A had a lower score on average. Because remember, the median is the average. So on average, test A had a lower score, which I would say makes it more difficult. Okay. You could also compare the ranges and the spread. Okay, but I'm going to compare the median here. How many marks is this worth? Just 1 mark. Okay, I'm going to go and say that test A is definitely going to be more difficult here. And then we're going to go and type in the answer. Okay, which is over here. Because the median, which means the average score, was lower. State the numbers. Okay, 20 is less than 35. Yeah, and you're really answering that question really, really well. Okay, if I can spell median properly. The median was lower. Okay, if you've got an average lower score, it's going to be harder. Okay, so there we go. Perfect. You could also write different things for this answer. You could compare maybe the higher score with the lower score, but just keep it simple, okay? And there we go. Done. And that is it for part A, guys. And I really hope that you're finding these videos helpful. I'm telling you guys, if you keep doing these homeworks every week and you mark the work using these videos, I'm pretty confident you're going to understand them fluently, and you're going to be exposing yourself to hundreds, if not thousands, of exam questions. These are actual GCSE exam questions. And if you do them and correct them, you're going to be doing so well, guys. I'm telling you. That is part A. We'll get on to standard form in the next